In this video, I'd like to demonstrate our EE3207 project. We have built a hexadecimal calculator using the Spartan FPGA board. So I'm going to first start off by hitting the reset button and beginning from the start. Now, you will see a keypad here using which I will enter numbers as well as operands as well as operators. And the LCD screen, there are two LCDs, 7-segment LCDs. The one on top shows the higher bit, the one on the bottom shows the lower bit. So I'm going to start off by entering any hexadecimal number. So let's say I enter 6. I've entered 16. Now I have a list of operators that I've created. This keypad doubles up as operators. So 1 is add, 2 is subtract, 3 is multiply, 4 is divide, 5, 6, 7, 8, 9 and so on are ANDs, ORs, XORs. And then you have single operand instructions which I will demonstrate shortly. So I have 16, so let's perform a simple add to begin with. So I'm going to click 1 is add, and then I'm going to hit, let's say, 55F. If I hit 5F, I get 75, which is the requisite result. Now let's try a subtract. Subtract 2B. I subtracted 2B, and I get 44A. And so on and so forth. We can also multiply 4A by 0.5. I get 72. So if the multiplication goes beyond 3 hexadecimal bits, the upper bit is ignored. Similarly, we have divide. Let's say divide by 0.3. So on and so forth. You can imagine how AND, OR and XOR work. I am next going to show you our single operand instructions. Now, a single operand instruction, of course, would not require us to add another operand. So we have made the system smart enough to automatically recognize such instructions and execute as soon as we enter such instructions. So B stands for complement. So swap. 26 stands for 62, and if I swap it again, I get 26. Similarly, I can move it right. So I get 1, 3 and 8, 9. If I move it back, I should get 1, 3 and 8, 9. Move it left and move it back right. And I can also complement it. So 68 became D9, and 26 became D9 and came back to where it was. Now we've also implemented interrupts. Now to show interrupts, we have these 4 basic LEDs, and all they do is they count. They count from 1, 0, 1, 1, 0, 1, 1, 100 and so on. Now we have 2 types of interrupts. This interrupt is a push button B is a level triggered interrupt. So as long as we press it, the interrupt will keep executing. So when I hold that button, it will keep incrementing the counter here. So I'm holding the button and it is incrementing the interrupt. Now I'm going to try level triggered. Level triggered interrupts will, even if I hold it down, it's going to increment only once. So I have to leave it before I press it again. So that's the difference between the two. Now the other thing I want to show you is that the interrupt actually stops the execution of the calculator. So this is going to be a little difficult to do with one hand. But let's say I execute an add. There's a small delay before the result is shown. So I'll hit the interrupt at that time, and you will see that the result is not shown. So I'm going to do 26, and let's add 3. Let's add 36. Okay, so it should give me 5B. So now, while I hit 6, I'm going to quickly hold this down. Just give me a second. 5, 6. So I've hit 36, and I'm holding the I held the level triggered interrupt. Let's do this again. The level triggered interrupt will execute, and then it won't pause the calculator. It will be done, and then the calculator will move on. So let's say I add 1, 5. So now I've added 1, 5, and you see I'm holding the level triggered interrupt. Now the moment I release this, I'm not going to press any keypad button. The execution will continue, and the result will be displayed, 71. So that shows the entire functionality of our project.